Hello everyone, and welcome to your third Apple debugging tutorial. In this tutorial, we're going to be diving a little bit deeper, talking about symbolic breakpoints, and there'll be a few other miscellaneous LDB topics in here as well. Now, before I get started talking about the actual tutorial, the project that you see in front of you is a new Cocoa project, so you can just do File New Cocoa project or a Mac application. And there's really not much here. The setup was that we did one without a storyboard, so it just has a main menu nib. And I added a button, added a label, and then I tied the button into the app delegate. So there is a IB action for the button into here. So when the button gets pressed, this method will be called. And then there's also an outlet for the label so that I can update the label text whenever the button is pressed. So if I click this, you can just see that we're incrementing our number of clicks. All right. And yeah, so that's kind of the idea. Now, let's talk about symbolic breakpoints. So a symbolic breakpoint is a way that you can break on a symbol that exists in your application. Now, previously we just said we want to break at a particular line, right? So when we just put down a breakpoint like this is just sort of us saying we want to break at this particular place. A symbolic breakpoint allows you to say, I just want to break on this particular method, essentially, that would be in your application. So there's a bunch of symbols that get resolved in your application, and you can think of them just as the methods that are exposed to the application while it's running. So we could break on, say, button pressed, or we could break when we call label text. The cool thing, though, is that we can also break on framework level methods. So if I wanted to break on something in AppKit or break when we call something in Foundation, I can also define a symbolic breakpoint that will stop when we hit something like that. Now in this application, we have a NS button and we have an NS text field that I placed in the nib file, right? These two guys here. And what I want to first try to figure out is I just want to see when the button actually gets created. So I don't actually have access to the, AppKit code that creates this button, but I want to simply say to the debugger, let's stop when we are initializing, or when we're initializing the button. So to do this, we go to our breakpoint section, hit the plus button down here, and make a symbolic breakpoint. Because all of AppKit is written in Objective-C, we need to have Objective-C symbols. So we do dash for an instance method, square bracket, NS button, init with frame. So that's one of the initializers that we could have. The other one that we could have is NS button, init with coder, like this. All right. And so let's go ahead and run our application. So I just ran the application, and now you can see when we rerun it, when we're setting it up, we are breaking on AppKit's NS button init with coder. Now, before I explain this page, I'm just going to briefly jump back to the breakpoints just to show you that when we typed in the NS button init with frame and init with coder, sometimes it might not resolve to any symbol right away, and it might not happen until you run the application. But if you run the application and you don't see anything under the chevron for the symbol that you wrote, or if there is no chevron, that means that the symbol didn't actually get resolved to anything. So that means the debugger didn't understand what you typed in. And this is just important to know so that you're not wondering why your breakpoint's not being called. So here we can see that this symbol for NS button init with frame did get resolved to NS button init with frame inside of AppKit. All right. Now let's go back to our debug navigation section here, and let's talk about this a little bit. So on the right, we have the assembly code for AppKit's NS button init with coder. And I'm not going to dive too much into assembly code today, but that's really what you're seeing on the right. It's pretty much the lower level things that the computer does to actually understand what it's doing. On the left, we have the call stack. So we can see here that if I click in, we can see that we were going into our main method. And then we are calling into application, NS application main, which is basically loading the application. Then we have some nib loading down here. which then does a bunch of unarchiving. That's essentially how nibs work, is they are just unarchiving, and then we essentially call into init with coder so that we can decode whatever was in the archive, and that will be our initializer for the button. So you might be asking, okay, this is great. What can I do with this information though? Well, we can figure out what button we're actually calling into. Now, the way we can do this is in our console down here. We can just say arg1. So if I PO arg1, we can see that we will get out NS button. And I know that this is actually the button that I put inside the nib file because there are no standard NS buttons on a plain NS window. So this is the button that I'm loading, just so you know. Some other arguments. So arg1 is the first argument to the method. And the way Objective-C methods work is you have the object or the instance that's being called upon, so the NS button in this case. Then you have the selector, which is the method name, and then argument 3 would be any of the arguments after that. So in the init with coder case, the argument that's going into the method, so in init with coder, that is a unarchiver, for example, then what you're actually going to get is for argument 3, you would get that keyed unarchiver. So let me just keep going here though with the arguments. So if I PO arg2, you'll see that the debugger doesn't quite understand what this is, but if I just print and I pass it, or I cast it to the type that I know it is, so it's an Objective-C selector, which is capital SEL, I can print out that, and you'll see that I will get init with coder, which is the method that we're being called. And then lastly, if I try to PO arg3, you'll see that the object is an NS keyed unarchiver. So that is really the first parameter that we see as a user, but in terms of Objective-C, it's really the third parameter that's actually passed in. So again, it's just the instance of the object that you're calling this method on, then argument 2 is the method itself, and then argument 3 are all the parameters that you would be passing along. And then arg4 would also be anything else, but this obviously doesn't have any other parameters. Okay, let's go ahead and continue. So if I want to continue, I just hit the little continue button over here, and we'll actually be stopping at another button. So if I want to PO, just to figure out what this object is, I can PO arg1, and this is the NS theme close widget, which is actually part of the buttons that are part of NS window. And if I just keep continuing, I can kind of keep seeing what different buttons are being created as I go. And once I've continued after that, we can see that actually every button has now been initialized on our window. So that's one example of doing a symbolic breakpoint. Now, let me just quit this, and I want to add or change one of my breakpoints here. So if I want to change an existing breakpoint that I have, I can go to edit the breakpoint. And what I want to do is I actually want to change this so that I will be notified whenever NS controls init with coder is called. Now the reason I'm changing this is because NS text field is a subclass of NS control, and so I just actually want to be able to break on both when my button and my text field are being created. I'm going to get rid of this init with frame just so that I don't hit them again. And so now I can run my application, and we can see that I've hit NS control init with coder. If I PO arg1, we can see that this is my button. If I continue once more and PO arg1 again, we'll see that this is my NS text field. And just so, I'm not sure if I explained that, but if you hit the up button, that'll give you the previous commands that you've typed in. So you can keep going up, keep going down, right? Just so you know. One more thing that I want to point out is that on the left we have all the registers that are passed in for the assembly. We'll talk about these again a little bit later, but just so you know, that's what we have over on this section if you go to the all variables, registers, etc. All right, now that's great. So we understand now how to stop in an Objective-C method. How would we stop though if we wanted to break on a Swift method? Now it's a little bit different. The syntax is Swift syntax. And so let's go back to our breakpoints. I'll add a new symbolic breakpoint. And I'm just going to want to stop whenever I hit application did finish launching. So I'm going to copy that. And I'm just going to paste that in here. So application did finish launching. Now, you'll notice it hasn't resolved to anything yet. If I run this again, it should resolve to the other things. So here's our to NS control init with coders. And then here's our breakpoint for application did finish launching. Now, you'll notice that we actually had two different breakpoints resolve here. And if I expand this out, you'll see the full crazy long Swift method name for this. But there are two different breakpoints that are generated. There is the Objective-C exposed application did finish launching, and then there is the actual Swift implementation that we wrote. So it's a little confusing, but when you're bridging between Objective-C and Swift, there are these two generated for you. And so the one that we're breaking in right now, you can see, is the Objective-C version of that. I don't really care about this one because I can't do much here, but usually I would want to break into the one that, you know, we wrote, for example, if I wanted to break on application did finish launching. Now, if I only wanted, you know, one of those to show up, I could just disable the Objective-C breakpoint if I'd never wanted to see the other thing. So let me just rerun this now that I've done that. So disabling the add Objective-C one. So we have our two buttons, or our two controls rather, and then here we'll hit the app delegate one that we've written ourselves. All right, so that's cool. Let me just, so I'll leave this up running over here. One thing I'm going to do is show you how you can actually find breakpoints that you might not know about. So if I pause, for example, so here I've now just paused arbitrarily in my running program. And let's just say that I wanted to look up some method that I didn't quite know. And the Swift ones in particular can be difficult. And if Xcode, for whatever reason, doesn't resolve them for you, and you're not quite sure why, you can look them up to see what the symbol actually is represented as and copy and paste that. So if I wanted to just find where the symbol is for application did finish launching, or what the symbol is, I can do an image lookup. And there are two parameters that, or two options that I'm going to use here. -R means regex lookup, which for, I'm not going to dive into regex at the moment, but it basically just allows you to look up sort of a part of the function that you might want to look up, and then it will find anything that is part of that. It's more complicated than that, but for our purposes, it's just going to let me type in part of the method name and it will show me the rest. And then the N stands for name, which just means that I'm looking up a method name as for my symbol. All right, and now I can look up application did finish. And I don't need to type the whole thing. I'm just going to type that in. And you'll see that we get any results that we found when we were looking for this. So you'll notice that there are two matches found, and they're found in the things that I built. And here are the two different methods. So we have the Objective-C version, and then there is the Swift version right below it. And the nice thing about this is that it'll actually give you the full method name that you can just copy and paste here. So now if I wanted to just delete the symbol that I have for application did finish launching, I could go ahead and add a new one. I could paste in the symbol that I just copied, and now it's only going to resolve to that single application did finish launching, which is the Swift version of it, not the Objective-C one. So if I go ahead and run this and skip over my NS controls, and now we can see that as we expected, it's going to break on application did finish launching. Okay, so let's talk a little bit more about breaking in the application. So what I'm going to do is just continue past this. And I'm going to pause the running application. So we've made it past all of our breakpoints. I'm just going to stop our execution, or pause our execution. And I'm just going to kind of poke around to see what we can find here. So if I wanted to kind of get to some of the views that exist in my application, what we can generally do is just ask NSApp for its delegate. And then I could ask for the window. And I could kind of just keep digging on this if I wanted. I can get the content view, right? This is just an easy way to kind of poke into different parts of the application. What I can even do here is there is an internal method in in AppKit that allows me to print out the subtrees. So if it's just called subtree description, and you'll see that if I print this out, it'll actually give me a printout of the subviews. So our content view is this guy up here, then we have the button that we put on screen, and then we have the text field that is there as well. And there's a bunch of other like useful information down here to show whether maybe a view has been marked as needing display or whether it's flipped and various other things. So this can be kind of a useful tool to figure out different view states if you're just pausing in the debugger. All right, so let's continue here. One thing I want to show is there's sort of this concept of different contexts in LLDB. So you'll notice that when I just pause the application, the context that I get put into is an Objective-C context. And you'll know that because I'm putting square brackets. And obviously square brackets are an Objective-C thing. They're not a Swift method syntax. Now the difference is, let's say, for example, I just place a breakpoint in here. So whenever my button's pressed, I could just put it in button pressed if I wanted. So let's go ahead and put a breakpoint in button pressed. And when I click my button, you'll see that I actually get placed into a Swift context now. So if I just hit up a few times, right? So if I try to PO NSAppDelegate, you'll see that we actually get an error because it's trying to, it knows that we paused in a Swift context and we're trying to use Objective-C methods. So if I wanted to use, if I wanted to do this still, I'd have to use Swift code, right, to access different components. So that's fine. I can do that, right? And because I'm actually paused in the AppDelegate, right, I actually have a reference to window. So I don't need to dig through the AppDelegate to do this. I could just PO window like that. And I could even get the content view. And let me just unwrap it so it's a little more clear. So that's how we can operate in a Swift context. Now, the one issue when you're operating in a Swift context, though, is that there's no great way to access private methods. So one of for example, the subtree method, right, this underscore subtree description, is a private method that we couldn't access using Swift because Swift has to know about all of the methods that exist on a class. And because it's not publicly accessible, the nice thing about Objective-C is you can just basically pass any selector you want and hope for the best. And if it exists, great. So we can cheat a little bit by essentially taking the context back to Objective-C. So we're going to switch the context. And the way I can do this is say expression-L. And I'm going to change to Objective-C. And I'm going to print in object format like this. So -O means printing out objects, and then just -- to finish that off. So if I do this, now I'm going to have a problem where I actually don't understand what the context of window is. So because window was taken from the context of Swift, and I've just changed the context to be Objective-C, it actually doesn't understand what the window variable is because all the variables that we stopped in were in the Swift context and they're not in the Objective-C one. Now, there is a trick to work around this where we can actually use backticks. So if I just use a backtick, so it's just the key in the top left of your keyboard. So backtick around whatever expression I wanted to use, it'll take the context that I paused the execution in. So because we paused in a Swift context, the backticks will evaluate the expression in the context that we paused in, and then it will basically give that result back to the Objective-C context, which is pretty neat. So if I run this now, you'll see that I actually execute that in the Swift context, and then it will give me the result in the Objective-C one. The nice thing about this is that I can actually now do the subtree trick. So I can say, what is my call subtree description? And oops, I screwed up where that backtick went. And there we go. So it's kind of a crazy convoluted way of getting this to work. But if you're pausing in the Swift context and you need to use a method that, for example, you don't actually have access to, the nice thing about Objective-C is that you can just call arbitrary methods, and if it works, great. So that's a nice little trick with the backticks so that we can analyze that. The very last thing that I want to do on the symbolic breakpoints front is talk about how we could analyze when this string on this label is going to change. So every time I press this button, right, we're changing the string value on the label. And so I'm going to add a new breakpoint for that. So over here, we're going to add a new symbolic breakpoint. And the symbolic breakpoint is going to be on NSControl because the label actually doesn't have set string value on it. So again, because this is NSControl comes from Objective-C, right? We have to write our symbol in Objective-C. So NSControl set string value is that's the equivalent of this call right here. So let me just continue our execution. Let me just get out of that because I kind of am just jumping through context here. But so we created our new breakpoint, and you can see that it resolves in AppKit. Go back to our application. When I press the button, let me just get rid of this breakpoint as well because I don't want it anymore. Okay, when I hit the button, I should be calling into set string value, and when I hit that, we can see that is indeed what ends up happening. Now, if I want, I can see all the values like we did before, right? I can PO arg1, for example, and we can see that I'm in our NS text field, which is great. I can also print out different argument values. So remember, argument 3 will be the first parameter to our method, and we can see here that it actually represents the string that we're passing into the control, or our NS text field. So one thing that we can do is we can actually change what this argument will be. So one way that we can do this, we can just create a new Objective-C string in this case, or an NS string, and then we can actually assign that back to the argument. So if I want to do this, I can just create a new Objective-C string, and because I'm in an Objective-C context right now, I can use, @. This is Swift strings, or not Swift strings, Objective-C NS strings. So I can say hello from LDB. So this will create a new instance with that string in it. If I just copy this address, I can actually reassign this now to the register of arg3. So I can just say register write arg3, and I'm just going to paste the address that we just created here. So what this is going to do is it's going to write into arg3 with this new address that holds this Objective-C string. And if I do that, and now I continue our program, you can see that our label actually gets changed to the text that we set from LDB. All right, so I think that covers most of what I wanted to talk about for symbolic breakpoints, and obviously there's a few other miscellaneous things in there as well around LDB, but hopefully that was fun, and there's lots more to learn around these things. And yeah, so just keep subscribed to the channel, and check out next week's tutorial for more debugging fun. See you then.